Hello and welcome to the final lesson in the series of lessons that was covering delegates, anonymous methods, and lambda expressions. And we're going to finish this sequence with the topic of events and how we use delegates, anonymous methods, and lambda expressions to fulfill that need of events. Now really, an event is really just a way for one object to subscribe to events that are happening within another one and then do some sort of logic around that. So let's go ahead and jump into Visual Studio and look at a little code to show you an example of how events work. So here we are back in Visual Studio, and I'm going to click on File, New Project as I've done before. I'll select Console Application and click OK. So now we have our boilerplate code. So let's set up this example a little bit. Let's say that you or some other people are interested in keeping track of what time it is and certain events within the clock to know when it's time for you to wake up or to go home or to do other events in between, but those are really just the ones that we're going to be concerned with in this example. So the way we would start this out is we would have a public class that would be person, and for now, to keep it simple, we will create a private field that is going to be a string name, and we'll have a constructor, and that constructor is going to take in one argument, and that's going to be a string name. And just to differentiate the two, I'm going to make this private with an underscore name, and then I will assign underscore name equal to name. There we go. Nothing really strange or new here. Now, we also need to have this concept of this other object that we want to watch or that we want to subscribe to events on. In this case, it's going to be a clock tower. So we're going to have a public class clock tower. And within this clock tower, it's going to be fairly simple for now. There could be very intricate levels of detail in here about keeping track of time or having timers in here and doing all that sort of thing. But we're going to keep it relatively simple for our example. And there's going to be two methods. We're going to have a public void chime 5 p.m., which is going to signify that it is time to leave, which isn't going to do anything just yet. And we'll have another method, public void chime 6 a.m. And it is also not going to do anything for now. Now, what we would like to be able to do is we would like to create a person and a clock tower and be able to have this person watch a particular instance of this clock tower and do some sort of logic or do some sort of activity or execute some sort of method in our instance based on when one of these things happens. So how do we do that? Well, that is where the concept of events and delegates come into play. So the way that events are typically wired up, now there's many different ways to do it in many different varieties, but typically what you're going to see is there's going to be some sort of what's considered an event handler, which is really just a delegate. So we're going to create a public delegate. It's going to have a void return type, and we'll call this chime event handler. And for now, we're not going to give it any arguments. So it's just going to be very plain. It's going to have a void return type and no arguments at all. So the next thing that we need to do is we need to wire up this clock tower so that it is available to broadcast events to a series of objects that are subscribing to a particular event. So the way that we do that is we create a public event within our clock tower. And the public event, an event is really just a glorified delegate at the end of the day. And you're going to see how that all kind of works here in a moment. Now, this particular event needs a type, and that type needs to be a delegate type. So we're going to use the chime event handler that we've just created, and then we're going to give this a name of chime. So that's going to be the activity. That's going to be the event that other objects can watch for and then do some sort of reactionary activity based on that event. Okay, so now once we have all this wired up, now we can start to broadcast these events a little bit. And the way we're going to do that in this simple example is every time that we call one of these methods, now like I said, we could put some very intricate logic in here to figure out when it's a certain time, and we could have any number of methods in here to chime when a certain time is hit, but we're going to keep it relatively simple. And in each one of these, we are simply going to call the chime event. So now what's going to happen is every time that some person or some object subscribes to this particular event, which is a chime event handler, they're going to be notified when something has happened. So the way that we do that now is we're going to within our person constructor, we now need to pass in a concept of this clock tower so that this person has access to it and can, quote unquote, watch it. So we'll create another private field here, private clock tower, and we'll call it tower. And then we'll take one in our constructor, clock tower, tower, and we will initialize our tower. So there we go. So now the person has access to this tower, but that's not enough. He needs to be able to watch for this particular event. And the way that we do that is within our constructor or anywhere else that you would like, but since I'm getting this clock tower instance in my constructor, it makes most sense for me to do it here. I am going to access the chime event that is within that tower. And now, if you remember from our previous lessons about delegates, one of the cool features of those things is the concept of chaining. And that's basically what we're going to do here. We have now access to this reference of a clock tower, and we are going to chain onto this chime event our custom logic that we want to do once this event is raised. And the way that we do that, if you remember before, is to use the plus equal sign. And now we can add on to here a number of different things. We can add on to here any sort of delegate, anonymous method, or lambda expression that we've covered in the previous two videos. So as you can see here, by default, it wants us to press the tab to insert, and if you see what it's going to do is it's going to create this method for us, and so we're basically using delegates here to chain this together. So that's fine. That's kind of like the old school method. It will definitely work, but like I said before, we're getting to the point where in the evolution of delegates, you probably want to be using the latest and greatest, which in our case is going to be lambda expressions. So I'm going to chain onto this event a lambda expression that's not going to take any arguments. Now remember, because chime is a delegate and it implements this chime event handler, your lambda expression needs to match the signature of this delegate, which would be a void return type and no parameters. So in lambda expressions, the way we do no parameters is we specify an empty parenthesis set. And then remember, we do our lambda operator, which is the little equals and greater than sign, the little smiley face. And then we put in here whatever we want to do when that particular event occurs. Now, if you wanted to state multiple expressions or multiple lines in here, you would probably want to encapsulate them within these curly braces. But since I don't really care for this example, I'm only going to be doing one thing. I'm simply going to be doing a console write line. And in this example, I'm just going to put out some formatted text to say, whosever name heard the clock chime. And we'll put in the name property, or field, excuse me. So now we can build this, see if we've done everything correctly. Great. And now if we run this, you're going to see that nothing actually happens. Okay, so now what we want to do is we want to wire all of this up. So in order for this to work, we need a new instance of tower. So we'll create a new clock tower. We'll create a new person, and this person is going to be John, is equal to a new person whose name is going to be John, and we'll take in this instance of tower so that he has the ability to watch it and wait for certain events to take place. So now if we were to run this, you're still not going to see anything happen, and the reason for that is because the tower actually hasn't chimed yet. It hasn't given us any information about an event that we've subscribed to. So we've subscribed to the chime event, but that hasn't actually happened yet. So we're going to force that in this example so we can at least see something happen, and we're going to make sure that the tower chimes 5 p.m. So when that happens, now when we run this, we would expect to see that since we are forcing it to chime 5 p.m., that it's going to invoke the chime event handler, which we have subscribed to in the person class, and we would expect to see the console write line that John heard the clock chime on the console. So let's go ahead and do Control F5, and there, of course, we have it. So John heard the clock chime. Okay, that's pretty cool. And, I could do another one if I wanted to. I could copy this, and I could create a new person and call this Sally. And now we'll give the name a value of Sally. We'll save, and we would do a Control F5, and now both people see that clock chime. So John heard it chime and Sally heard it chime. Well, that's great. So we could do this all day long and create as many of these as we want, but the problem that we're going to have now is that even though we have subscribed to a particular event, the event is being fired on both of these methods, and the problem is going to become that we won't be able to differentiate which one has happened. So we have chime at 5 p.m. and chime at 6 a.m. Now, if we run this, we're going to see we heard it chime both times, but we don't actually know which event was being raised. Now, sure, the naive way of doing this is we could create multiple events, one for each type of activity that is happening within our clock tower, but that would be a lot of maintenance and a lot of problems that could arise because of that, because we could have basically an infinite number of events happening in a clock tower. We could have it at seconds, nanoseconds, milliseconds, hours, half hours. We could do it however we wanted. And we don't want to have to maintain that many events as well. So another way to get around that is with the introduction of the concept of event arguments. Now, the way you use event arguments is what you tack them onto your delegate. Within our handler here, we're going to say, now typically the way you do this is you want to specify whichever object is actually raising this event. So we typically would see something like this, object sender. So you could pass into this particular delegate who is raising this event, and then you would pass in the event args class, or an instance of the event args class, so you could see some more information about what's going on. Now you're going to see things are breaking here, so we have to fix this a little bit. So when we raise this event now, we have to pass in some arguments, and if you look at the IntelliSense, we need an object sender, which in this case is going to be this object, and we need event args. Now, for now, I'm just going to say that this is the event args empty because I don't really have anything to pass into it just yet, and we'll do the same thing here, event args.empty. Now we can save this, but now we have to modify our lambda expression a little bit because this delegate or this lambda expression now needs to take in two parameters, namely an object and the event args. So I would simply specify those in here, object sender, event args, and now I can save this, do Control F5, and everything still runs again. Now we're able to pass data into that delegate, to that lambda expression, but we're not really doing anything with it yet. So one way to get around this is to pass custom event arguments that are necessary and that are descriptive about the particular events that are happening. And since event args at the end of the day is merely a class, we can create our own version of that. So let's create a new public class called Clock Tower Event Args, and this is going to inherit from event args, and we are able to specify any number of things in here that we would specify within a class, and in this case I'm simply going to create a property. It's going to be an int, and the name is going to be time. So I can save this, and now instead of passing in here event args, we're going to pass in clock tower event args. So I will need to pass into the chime event here a new instance of my clock tower event args, and I'm going to initialize time in this case. Since it's 5 p.m., we'll give it military time, so it makes a little bit more sense, of 17. And we'll do the same thing on the chime 6 a.m. method. We'll give it a new instance of clock tower event args, and we will initialize time equal to 6. All right, we can save this. We now need to modify our lambda expression to accept the clock tower event args. Now we can save this and execute again. Now everything continues to work, but now we've gotten to a place where we have supplied meaningful information to this event. So now instead of just saying that I heard the clock chime, I want to do some sort of custom logic, some custom operations to handle this particular event. Now since I'm going to be adding in multiple lines to this lambda expression, I need to write them within curly braces. So I'm going to copy or cut this line, and I'm going to paste it within these curly braces, and I can continue on. So not only did this person hear the clock chime, but he wants to do some sort of custom logic in order to handle that particular event. So now I'm going to do, very simply, I'm going to do a simple switch statement, and I'm going to switch on the args.time property. And I'll just write in a couple cases in here. In the case that it is 6, then we're going to do a simple console write line to say that this person's particular name is waking up. So at 6 o'clock a.m., this person is going to wake up. And then, of course, in switch case statements, you need a break. So I will break after that line. And then I will do another case of, this time we're talking about 17. and there will be another console write line to say that this particular person is going home after a long, hard day of work. We'll close that off and we'll break out of here, and now we'll save. And now what we would expect to happen is now we have custom logic based on these clock tower event args that we can do some sort of custom logic on. In this case, it's a very simple switch statement. So now when I create my person, John, and he takes in an instance of the clock tower and subscribes to the clock tower chime event with a lambda expression to say that I heard the clock chime, and that if the clock chimes 6 o'clock, then I'm going to wake up, and if it chimes 5 o'clock, I'm going to go home. So now we can execute this with Control F5, and so now we're seeing that John heard the clock chime and he's going home, and then John heard the clock chime and John is waking up because it chimed both 5 p.m. and 6 a.m. So of course, if I removed one of these, chime 5 p.m., save and execute, this time he's only going to hear the clock chime and then wake up. So this is a very basic example of events and how they are related to delegates, and basically at the end of the day they are really just another version of a delegate. And then when you are subscribing to particular events, all you need to do is basically concatenate or aggregate onto those or subscribe to those events, and then you can do any sort of logic you want here within either a delegate, an anonymous method, or a lambda expression. So I hope this whole series of those three topics have really been useful for you. If you're doing things like web development or Windows programming, you're going to be using a lot of events, so it's very good to have this type of knowledge in your tool belt. And if not, you can definitely do it in any sort of other programming where you need to be subscribing to events and doing some more of event-based programming. So I hope you've learned a lot in this lesson. I'll see you in the next one.